Hey, welcome back to Hex and Cube Map Generation Visual Scripting using uNode Part 4. In Part 4, we will go over mostly arrays. So we're going to be setting up and using arrays to define the directions of either the hex or the square. In this particular case, we're going to start off in the start method of the game manager, and we will basically set this up so that if it's a hex, we'll go into another if statement, and if it's a pointy hex or a flat hex, we'll do some stuff, and then if it's a square, we're going to determine if we want diagonal movement or not, and then if it's an 8 or 4 direction, we'll do some math based on that. So in this particular case, we're going to go ahead and create a couple of variables. We are going to create is diag movement, so that we know if it's going to be going diagonal on a square movement or just straight across. So basically an 8 movement or a 4 movement. I'll go ahead and move this up to the top, and then we also are going to have a couple of additional variables. We will need. We're going to create is auto start, so that'll be a boolean. Is diag movement, that'll be a boolean. We're going to create directions, that'll be a list of vector2. Now go ahead and drop in, starting in the start method, we will drop in a couple of if statements. One will be if it's a hex, so if is hex, we'll get that. And the next one we're gonna get is if is diagonal is diag movement. So we want to check to see if that's a diagonal movement, and if it is, we'll do different code based on if it's 8 directions or 4 directions on a cube or square. Next, we'll go ahead and create a boolean is show nodes. This will allow us to turn on and off the connectors of the nodes between the hexes or tiles if we so desire. Alright, so once I finish moving this to the boolean section of my variables, we're going to go ahead and create an array based on the directions of each of the pointy hex, flat hex, which is 6 directions, so it'll be an index of 0 through 5, and then we'll have an 8 direction or 8 index array and a 4 index array. So we're going to have 4 arrays here. So we're going to go ahead and just click right click on the canvas, add node, and then make array, and then we'll have copy and paste 4 of those because we'll need 4 of those. And here's we're going to check and see if it's a pointy hex, and so we're going to do 1 array if it's flat, 1 array if it's pointy, and then 1 array if it's 8 directions and 1 array if it's 4 directions for the cube. Alright, now that we have them all kind of organized and labeled, we will go ahead and set each of the make arrays. So we want to put an int in the first drop down, and then type in 6, which would be the 6 directions of the first hex. Over here on the top right, we need to set it as a vector2. And this drove me crazy to figure out where this was initially, because we're setting the directions array anyways, so it's kind of redundant, but you do need to set the make array to an array of what you want to set. Go ahead and drag the directions variable onto the canvas and select set. We're going to go ahead and set the array to directions. think we need at least one direction, so it's defaulted there. So it's the pins are the same pin type. So we might as well go ahead and set the rest of these to a vector 2, and it's not an array, right? So it's you're setting the make array as a vector 2, and that's it, right? So I'm gonna go ahead and select the vector 2 on all of these, so I don't have the trouble I had earlier. And then you can also select default. It would make the pin output the default, which is the vector 2 that we want. So each of these arrays are going to be setting the direction, so we'll go ahead and just copy the directions variable, or you can drag and drop it from the variables list 3 more times so that we have a set for each of these. I did not set that to vector 2 and select the select button. So make sure you don't forget to set the select button when you drop this menu down. Select vector 2 and then click select. There we go. Alright, now we're going to go ahead and just set the arrays up with the amount of slots that they need. The first 2 are going to have 6 slots for the hexes. Then we'll have an 8 slot for the diagonal movement square. There we go. And then we'll have add 8 here. Make sure that all of the entries or slots are set to a vector 2. And there's 4 for the last one. There we go. So we're going to go ahead and put a region around each one of these and colorize it as you see fit. One will be a flat top, one will be a pointy top, one will be a 8-directional cube or square, and one will be a 4-directional cube or square. Alright, now that we have the regions around everything, and we're going to kind of move some stuff around so there's a little bit more room between each of the groupings, then we'll go ahead and get started with probably the 4 direction one. It's the easiest one to do since there's only 4, so we'll start with that one. We'll get a little bit more room for each of these because we will need some room off to the left of the make array section. For all of these, we'll be doing a new vector 2. So right click on the canvas, select add node, and then click on new vector 2 with the 2 options available, both floats. There we go. We can use either one of those. We can drag out or go find it. Your choice. And then what we're going to do is copy this because we will need it 3 more times for this one. For the cubes or squares, we're going to use the tile width to define the direction for each of the directions of the cube or square. So here we're going to put the tile width in the X and Y of 2 of them. And then we're going to do get the tile width and the negate that, or the negative of that. So we'll go ahead and find that. And really we're just doing the opposite of what we just did before. So the negate is going to be on the X of the second vector 2 and Y of the last vector 2. See if I can squeeze it in here. Last thing we need to do is make sure that we connect the new vector 2 pin out value to the make array slot that it's designed for. So we're going to drag in the second vector 2 pin and plug it into the element 1, element 2, and element 3, just like that. Alright, there. I think our 4 directional square is now complete. Alright, now that we've created ourselves a little bit more room, we're basically going to do the same thing as we did the 4 direction with this 8 direction. We're going to use the tile width, and we're going to set up basically the same first 4 that we already did, and then the next 4 are going to be a little bit different. But nevertheless, we will need to get the negate, we'll get the tile width, Right, so you can either grab a new vector 2 or copy and paste it from the previous section, whatever you find to be easier. And then what we'll do is just copy these down, so there are 8 of them. Alright, now that we have all 8 of them copied in, we might as well go ahead and connect them into the make array section. So all of these will go into their appropriate slot, 0 through 7, and we plug them all in. So you can either drag in an individual tile width for each of these new vector 2 floats, or you can reuse, similar to how I did in the 4 direction. I kind of reuse the tile width. It's up to you. Either way works. Sometimes I find it to be a little bit easier to read the code, read the canvas code if they're individual. This will get a little, there'll be a lot of lines, and you kind of lose the where they're coming from or where they're going to if you don't have them individually, at least in my opinion. So in this particular case, I will drag in the individual tile width for each of the new vector 2s that we're going to set up. So the first 4 will look very similar to the previous 4 that we did for the square, because it's going to set up the 4 base directions, and then we'll set up the 4 diagonal directions. Next thing we're going to go ahead and do is to tile width to tile width. And then we're going to do tile width negate and tile width negate. So they're basically all the same. Here we go. There's the first one. The second one that we do will look exactly like that, but with negate instead. And the last 2 will be basically 1 tile width and 1 tile negate width for X and Y, and then flip them for the next or the last one. So we'll go ahead and show you how to do that here. There's the 8-directional cube square. That looks all good to go now. Now we'll move on to the hexes. For each of the hexes, we'll need 6 new vector 2s with both float options. So we can go ahead and copy those in and connect them into the make array. In this particular case, for the flat hex, we are going to use tile height for the get variable. So we will move tile height into the y value, and then we'll do tile height negate into the y value. Here we'll go ahead and grab the tile width and we'll do some math. This is all based on hexagonal math and directions based on that math. You could check out redblobgames.com for additional math and information around hexes if you so desire. I think that's where I probably originally got this. So tile width multiply 0.75 into the x value. Then we'll do tile height divided by 2 into the y value. Alright, the fourth vector 2 will be the tile width multiplied by 0.75 into the x value, and then the y value will be tile height divided by 2 negative, or negate, into the y value. The fifth element will be the tile width multiplied by 0.75 negative into the x, and tile height divided by 2 into the y. And the last one, the sixth setting, or for the vector 2, will be the tile width multiplied by 0.75 negative as the x value, and tile height divided by 2 negate or negative into the y value. Alright, I think that finishes up our flat hex 6-directional array. Alright, last one we have to do is the pointy hex directions. Again, this is 6 directions, which we have already kind of set for the make array. Make sure there's 0 through 5 elements listed there. And then we are going to create the new vector 2s, and we'll need 6 at the new vector 2s. And in this particular case, we're going to use the tile width and tile height again. Just a little bit different math. Alright, the first new vector 2 will be the tile width in the x, and then nothing, 0 into the y. The next one, the second vector 2, will be a tile width negative into the x, and y will be 0. The third vector 2 will be tile width divided by 2 into the x, and tile height multiplied by 0.75 into the y. I know for each of these I'm just going to need a divide and multiply for all of them, so I just copy and pasted those in there quickly so I can leverage those. We'll also need a negate in here for a few of them, and then I'll just start linking them all together from pin to pin. So the third pin will be tile width divided by 2 negative to the x value, and tile height multiplied by 0.75 negative into the y value. The fifth value is tile width divided by 2 into the x, and tile height multiplied by 0.75 negative into the y. And the last vector 2 will be tile width divided by 2 negative into the x, and tile height multiplied by 0.75 into the y. And that about finishes up part 4. We have set up the directions for the 2 6-directional hexes, both pointy and flat. We've set up the 8-directional cube and the 4-directional cube. So I think that all of that is good now. We'll go ahead and compile it, and there's not really anything to show yet. So we'll have to come back to part 5 and put all of this actually into action. Thanks, and see you next time.